Here we will solve an application problem involving logarithms. If you haven't already, take a second to pause the video and read through the question, both the problem setup and the individual parts. And you can see I already have the answers marked here, but I want to show you some of that scratch work that leads to those solutions. All right, so we're given this model, r equals 3 times e raised to the kx, and we are told a specific value here that when x is 0.04, r is 10, and asked to solve for k to begin with. So let's do that part here for part A. When r is 10, we're asked to solve for k. And as well, x is 0.04. All right, so just like any other logarithmic equation, we want to start by isolating the exponential piece. I said logarithmic, I meant exponential. So it works out the same even for logarithmic, but we want to isolate that piece. So in other words, divide by the 3 first. Okay, so we get 3.3 repeating, right? And next, what we want to do, and I do want to keep several decimal places, or even in my calculator refer to this as the previous answer or the fraction, because the next thing I want to do is rewrite this exponential equation into a logarithmic form. Because the base is e, I don't have to write log base e, I could write natural log of 3.333 repeating, or just include several 3's, equals the exponent. And I'm going to reorganize this if that's okay, 0.04k. I mean, it's the same thing as k times 0.04, but I think it's a little bit more standard. So after that, what I would want to do is divide both sides by 0.04. And just watch this in your calculator as you type that in, and you should get that k is approximately 30.1 or 30.10. All right, after that, we're going to keep this value of k for the rest of the problem here down. Okay, so just keep that in mind, that now that we've solved for that constant, it stays the same in the rest of the problem. So in the next part, part B, using the value of k, we've already found what's the relative risk if the concentration is 0.12. So that's an x value. In other words, if this is x, solve for r. What is r? So for here in part B, we're now solving this equation where we know k is 30.1 and we're given x is 0.12. So we could simply type in exactly what we see here on this side, and we can get that r is 111, rounded to the nearest percent. Or not nearest percent, rounded to the nearest whole number, actually. And then in part C, we're going about this one a little bit differently. So here we'll have to take some steps to solve. In this problem, we're given the value of r. We're given that r is 100, and we're asked to solve for x. So let me write down what we need. And with a little bit of space here, we'll start by dividing both sides by 3. And again, either keep several decimals, refer to it in your calculator as the previous answer, or better yet, just leave it as the fraction, 100 over 3. That's fine too. Change this exponential equation into a logarithmic equation. Base e means I can use natural log of 100 over 3 equals the exponent. And then to finish solving this, I just need to divide both of these by 30.1. And that should leave us with x equals 0.116. I believe we were asked to round to nearest 3 decimal places. Yes. And then in part D, using the value of k again, The law asserts anyone with a relative risk having an accident of 15% or more should not have driving privileges. So we want to find what is that value of X associated with R. R equals 15. Find X, in other words. So that's very similar to part C. So I'm going to write that one over here. Here we know that R is 15. And look at the parallels as we go through this. So I divide both sides by 3. And then I'm going to change this to its logarithmic form. I'll divide both sides by 30.1. And that should give me 0.05 whenever we round to 2 decimal places. Yes. So you see the parallels as we go through this and this solving for X process when we know R, when R is given.